So this is programming in Java. We are into the third module, part 1, which is introducing the classes. And we considered the, class fundamentals, and then the declaring how objects are declared and how object referencing is done. And then we also considered some of the methods associated with that, and also constructors and what is known as this keyword. So the agenda of today's class is garbage collection, finalize method, and the stack class. So going forward from here, okay. So we use the new operator so that we can allocate the memory, okay, to the objects. So since objects are dynamically allocated by using the new operator, or indirectly one can say to the variables we assign the objects, and those objects are basically allocated within the memory, present within the memory, and the variable might try to point to that. So creation is basically by means of the new operator. So once we say that creation is there, then how the what we call deallocation of the memory is done, or how the object is destroyed, and how the memory is released. So allocation and deallocation are the opposite terms. So by using new operator we allocate, but how is it that in Java the memory is released, or you can say the memory, the deallocation of the memory space is done. And later, whatever, the memory is made free by means of deallocation is again reallocated to some other, what you call objects. So in C++, a delete operator is used for doing the deallocation, okay, and that also by manually. So C++ dynamically allocated objects may manually be released, deallocated, or released by using what is known as delete operator, whereas in Java it is automatic. So that is done basically by what is known as garbage collection. So garbage collection works in the following way: when no references exist to an object. So when we don't have any references, to the object, that object is assumed to be no longer needed. And in that case, the memory occupied by the object can be, reclaimed. Reclaimed just means the what you call deallocation can be done. Can be done is very much important here, right? Okay, and it can be allocated to some other object. So there is no explicit need to destroy objects as in C++. We are not, user has no say. It is the JVM which takes care of all the deallocation by means of garbage collection. Okay, however, we can suggest, we can suggest the what you call garbage collector to do the collection, but the JVM need not accept it. So garbage collection only occurs sporadically. So that means, it just means that, once in a while it keeps on occurring, not that, the user has any control over it. However, again, the garbage collection implementation itself is variable for different JVMs, or rather different Java runtimes implement the Java collection in different ways. Okay, so there's no specific way for garbage collection. Different, Java runtimes implement it in a different way. So during the execution of a program, it will not occur simply because one or more objects exist that are no longer used. So not that, because they are not used, hence immediately garbage collection will occur. It is not that. Once in a while it occurs. Okay, the algorithm for garbage collection keeps on varying for each of the different Java runtime system. Okay, So we have continuously the what you call updation going on for the garbage collection. So with respect to the garbage collection, we have what is known as the finalize method. Before going to the might be the finalize method, we can just go through some of the what you call explanations in the by others, okay, how they have discussed. So Java garbage collection is the process of releasing unused memory. So basically, when we talk about GC or garbage collection, it is the process of releasing unused memory occupied by unused objects. So this process is done by JVM automatically because it is essential for memory management. So when the Java program runs on a JVM objects, JVM objects are created on the heap. Heap just means that heap is a memory where all the objects are placed. So which is a portion of the memory dedicated to the program. To each program, a heap memory is dedicated where all its objects are put, or all its objects will be later, once they are put, they have to be referenced by means of variables. Eventually, some objects will no longer be needed. We see that the objects might not be needed at some time. Okay, so when there is no reference to an object, then that object is assumed to be no longer needed. So if we don't have any reference, how to create a reference we already seen, right? By means of the basically a new operator, or might be assigning some value to it and all that. Okay, for example, say you can write string s, that will be declaring an object, then later x declaring a variable, later s is equal to, might be within quotes, you can write yy. So the YYY is a object, a string object, and S is pointing to that object. So that is what is referencing. S equal to XXX within quotes, or YYY within quotes, or ZZZ within quote, or some name. S is equal to whatever name you want to specify. Okay, that might be any string for that matter. Which is assigned to the variable S will be referencing, okay, will be the referencing. So whenever it is no more needed, then naturally it has to be released. So when there's no reference to object, then that object is assumed to be no longer needed, and the memory occupied by the objects are released. The garbage collection, what you call, is part of JVM. Basically, this is part of the Java virtual machine, and it is basically an automatic process done by the JVM. There's no need explicitly for a user to do anything about it at all. Okay, we don't need to explicitly mark objects to be deleted. User has no say in this garbage collection. However, we can request to the JVM for garbage collection of an object. It's just a request, but ultimately it is the JVM, which will decide. Okay, it depends on the JVM to call the garbage collector whenever it wants. So what you call that totally depends upon what is known as the Java runtime, which is part of the JVM itself. So unlike C++, there is no explicit way to destroy objects. In C++, we have a delete operator, whereas in JVM it is automatic. In Java it is automatic. So here we have a heap where objects are placed. So if there is no reference to the object, this object is not referred to anything, then we just release that. Okay, object is dumped and the heap is free. So memory is totally now free. Okay, so that can be done again by means of many different ways in which the heap is made free. So can the garbage collection be forced explicitly? It is not possible to force this. So no, the garbage collection cannot be forced explicitly. You may request JVM for garbage collection by calling what is known as system.gc method, but this does not guarantee the JVM will perform the garbage collection. So no guarantee at all. It will do in its own free time. Okay, so what are the advantages of garbage collection? Programmers don't need to worry about dereferencing an object. So whereas in C++, dereferencing or releasing of the memory is compulsorily being done by using the delete operator. In case of the Java, programmer does not have any control and programmer does not need to worry. The JVM takes care of that. If the referencing is not there for an object, it is done automatically by JVM, increases memory efficiency and decreases the chances of memory leak. Okay, it is increases the memory efficiency because user need not bother much about it. It's done automatically, but however, every frequent amount of time the garbage collection will do. But however, it should not be too many times also, because if it does too many times, then only garbage collection will be done. Running of the program will suffer. Efficiency might suffer. However, because it is taken care automatically, there are proper algorithms wherein only for 5% of the time, maximum 5% of the time, the garbage collection is done. Okay, so also there is a very less chance of memory leak because by garbage collection, whatever is dereferenced, object, whatever is unused will be automatically removed. And once it is removed, it cannot use the memory. So if an outside person gets hold of that object also, because it is no more part of the heap, there will be very less chance of the memory leak. So an object is able to get garbage collected if it is non-reference. We see that the object will get garbage collected if it is not in the reference. So we can make an object non-reference by using 3 ways. There are 3 ways to remove the reference, to do the dereferencing rather. Okay, after the dereferencing, then garbage collector can anytime remove it. So we have written here, one is by means of setting the variable to null. We are just putting the variable we have created here and declared here, and then we have created the object. So referencing is done over here. To the demo, we are referencing a memory, and later we are making this demo equal to null, and that is basically making it ready for garbage collection. Please remember that this does not make the deallocation automatically. By putting this, it does not deallocate, but it is ready for garbage collection. So the garbage collector within the JVM can do the so to say deallocation. Also, we can non-reference an object by setting new reference to it, which makes it able for garbage collection. For example, we are writing here to create, 2 variables over here, and each of those variables is pointing to a certain object, a new object over there. So that is, this is basically new demo is creation. This new demo is creation. Both of them will be, pointing to 2 different objects. Whereas when we write demo2 is equal to demo, then indirectly demo2 will be pointing to the object which is pointed by demo. Demo2 will be pointed by the object which is pointed by the demo. So what happens to the object which is concerned with demo2? It can be, now it is ready for garbage collection. Okay, dereferencing is already done, so it is waiting for the deallocation. Demo2 no more points to its original object, but to the object pointed by the demo because of the 3rd statement over here. This 3rd statement makes the demo2 variable point to the object of the demo, and hence it is no more pointing to its own original object, and hence now that particular object can be easily removed by the garbage collector whenever it runs it. Okay, whenever JVM runs it. So again, that just means that this statement will make the demo2's object ready for garbage collection. Demo2's original object ready for garbage collection. Similarly, we have the anonymous object. Anonymous object does not have any reference. So if it is not in use, it is already for is ready for the garbage collection. So if you have some anonymous object, then at that time also it is possible. Okay. Now let us see the next thing, which is generally known as finalize method, which is rather very important as far as the garbage collection is concerned. So sometimes an object will need to perform some action when it is destroyed. So we see that, you know, when the object gets dereferenced, then automatically later, you know, garbage collection can what you call deallocate the space. But however, it might be possible that the object is holding some non-Java reference, such as a file handle or character font. So if the object is holding a non-Java resource, such as a file handle or character font, then you might want to make sure these resources are freed before an object is destroyed. So before the object is destroyed by the, you know, garbage collector, you know, the object should stop holding the, you know, file handle or the character font. Okay, so only then it can be what you call destroyed. Only those external resources are freed, then the object can be declared. To do such situations, Java provides the finalize method, what is known as finalization or finalize method. So by using finalize method, we can define specific actions that will occur when an object is just to be reclaimed by the garbage collector. That means the resources like file handle or character font and all should be released, and that is generally done by the, you know, finalize method. To add a finalizer to a class, we simply use what is known as the finalize method, and the Java runtime calls that method whenever it is about to recycle an object of that class. So whenever it wants to, you know, so to say, deallocate the memory space, it will just what you call the finalize method and make it free whenever it is not in use. So inside the finalize method, you will specify those actions that must be performed before an object is destroyed. So whatever action which is releasing of the file handle or, you know, releasing of the character font and all that is there. Okay, so to do that action, we just implement it in the finalization code over here. Okay, finalize method, you will specify those actions that must be performed before an object is destroyed. The garbage collector runs periodically. So this is rather, we earlier mentioned sporadically. Now we are writing here periodically. And most of the time we see that it runs only for less than 5% of the time, so that it doesn't eat away the resource, the processor resource. So checking for the object that are no longer referenced by any running state or indirectly through other reference objects. So the finalize method is, you know, format is being mentioned over here, and we are mentioning that it is protected. So protected void finalize. So protected is between, you know, public and private. Public just means anybody can use it. Private means it belongs to that particular object class only. That particular what you call you know, objects of that particular class only, where the method is implemented. Okay, that is what is private. Protected is in between them. Okay, protected is in between them. We can say that it can be used by the finalize method. A protected method can be used by the what you call same class as well as objects of its parents class. Okay, same class as well as the object of its parents class in the hierarchy. We have a class hierarchy, okay, where we can say that we have a child class, a parent class, and a super, you know, parent class, and so on and so forth. So in the hierarchy, when we arrange the different classes, then the objects of a, you know, parent class also can use that what you call finalize method. Rather than telling the parent class, it is the children class can utilize that method. So here the keyword protected is a specifier that prevents access to the finalize by code defined outside its class. So it is important to understand that finalize is only called just prior to garbage collection. So just before the garbage collection, finalize is called. So it is not called when an object goes out of scope. That means if dereferencing is done immediately, it is not finalize method is not called. But when the garbage collection is about to be done, the finalize method is called. This means that we cannot know when. So we will not be able to know when the finalize method will be executed. Therefore, your program should provide other means of releasing system resources, etc., used by the object. Okay. So program, if the program needs some resources, then it should have its own mechanism of getting the memory rather than depending upon the garbage collection. Now let us see an example of the garbage collection, using a finalize method. So you can see here we have written public class test public static void main string args test t is equal to new test t equal to null. So here we are doing the creation and here we are doing the dereferencing. So now it is ready for the garbage collection by making t equal to null. We have seen different methods of that. This is one of the method. By making t equal to null, it is ready for the what you call garbage collection. So now we can what you call here we have implemented the finalize method, which is having inside it system.out.println garbage collected. Okay. So we are here trying to force it. Rather, we are trying to suggest to the JVM to call the garbage collector. System.gc will be calling the garbage collector. But however, the garbage collector can just ignore this method also, unless it is free. Okay, now let us try to run this code. So again, we need to change this, class name to main. If we try to run it within the online GDB, so let us try to copy this into the online GDB and try to run it. Then, it will try to print that when the GC garbage collector is called. It's rather slow again. So we'll try to see some code for that and see how that can be done. Then we have what is known as a stack. Okay, many of us know what a stack is. It is basically last in, first out, or you can say the other one way around, first in, last out. Either you can say it as first in, last out, or ideally speaking, last in, first out, Lec4. Okay, so we know that a stack of books, if you put, we can't remove it from below. If the stack of books, one of the book we remove from below, okay, in a stack of books, then all the books might fall. Similarly, if we have a set of stack of plates, if we remove from in between, then there is a possibility of other what you call plates falling. So we pick up the what you call plate from above, and we also place the plate above. So placing will be known as pushing, and taking it out is known as the popping. So we have two operations in the stack. One is known as pushing and another is known as popping. So I'm just pasting this over here, and I'll change this test to main. That is how the online GDB wants it. So now we can run it, right? So system.gc will indirectly call the finalize method. Okay, test t is equal to new test. Okay, we can't say that. Now this test is to be removed because it is no more test. It should be main. So anything more, I think it should be sufficient. Fine. Okay, so the garbage collector calls the garbage, the finalize method, and within the finalize method, we have put here the garbage collector. Okay, so this is the way which we can do. Let us see one more program. I think I don't know whether I have that at all because it was there, and if I have removed it, then it becomes a problem. Okay. We are running out of time. Fine. Let me see whether it is there here. This is a very good resource. If you want more information about the garbage collection, you can go through this. You can note the site and go through it. It is in much more detail than, compared to anything else. Okay, I think I don't have it. I'll write it in a different way, whatever code I have, right? Okay, so I have written here, main T. So I'll write here main T1 equal to new main. So I have created another object. Okay, so there are two objects here. Rather, two variables T and T1 pointing to two different objects by means of the new operator. We have created two objects. And later what we will try to do is we will put here, T equal to T1. You can put T equal to T1 or T1 equal to T, whatever you want. Okay. So by doing this, earlier we had, as I said, two objects, one where T is pointing, another where T1 is pointing. But suddenly by doing this, what it is doing is the T is pointing now to the object pointed by T1. By doing this, T is now pointing to the object of the T1. So T now is no more connected to the original object, and the original object has, is ready for garbage collection. Okay, it is ready for garbage collection, and hence, we will have that, garbage collected, type might be once. Let us see whether it is typed once or twice. I hope it is okay. It's only one. But say if I put here T equal to null, and further I write T equal to T1 equal to null. Okay, so both I am making them null. So it should print that garbage collected twice. Okay, by the garbage collector. So it is printing twice because both T and T1 are now, no more, so to say, connected to any one of the objects. Both the objects here, which have been created, are now free because we have put here null and null. So just putting T equal to T1 will make one of them free. By making both of them T equal to null and T1 equal to null, both will be free. Okay, both will be free. So T equal to T1 is equivalent to making, T equal to T1 is equivalent to making T equal to null. This is, what we need to understand. So whether this is of no use to me over here, right? Say whether I write T equal to null or T equal to T1, both are same, but only that the difference is T is also, in this case, T is totally free. Okay, T1 is pointing to still an object, but when if I write T equal to T1, then T is pointing to the object pointed by T1, and hence the original, what you call, object to which it was pointing here is dereferenced, hence ready for garbage collection. Try to understand this terminology, hence ready for garbage collection. Okay, so next let us try to see what you call YouTube video for stack. I think we still have time. This is only 1 minute video. I wanted to run the, okay, we'll continue for another, might be in the next session also if need. It's not showing anything, fine. So you can see that to the top 11 is added, then 23 is added. Top is moving up by means of the push operation. So push 27, top is moving up. Push 14, top is moving up. 20, top is moving up. So now the stack is full. For deletion, 20 is removed by means of pop 20. 14 is removed by means of pop 14. So you can, I hope you should be already knowing this, but this video gives you a clear picture of how the stack works, right? Pushing will be from the top, again popping also will be from the top, and the pointer top will be pointing to the top of the stack. Okay, top means the last so to say, the value being pushed in, it will be pointing to that. Okay, to the last value which is pushed, it will be pointing to that, and that is the stack is generally known as last in first out, or sometimes first in last out. Okay, either way we can talk about it, right? So now let us see the what you call code associated with the what you call the stack there. I think we need to go to the book itself, otherwise we don't have anything else. Okay. So we have seen how what a stack is. So here we are making the stack, what you call creating a stack by means of arrays, using the arrays. Okay, a stack can be implemented by using the array, or might be by using some other data structure such as linked list or anything of that sort. But here we have stack as implemented by a array. The array is stck, where we have maximum of 10 values. So class defines an integer stack, an array stack that can hold 10 values, and that is basically by means of a variable which is known as stck. So this is class stack, wherein we are trying to write this stck for to hold 10 variables, and we are writing here top of the stack also, TOS pointer also. Int TOS points to the top of the stack. So the constructor itself, each time we call it so to say toss the top of the stack will be pointing to -1. So when we push the next value, it is incremented by 1. If you pop one value, the TOS is decreased by 1. But however, the minimum value of TOS is initially -1. If you push one value, then -1 will become 0. Then one more value, if you push, it will become 1. So that, the top of the stack points to the what you call most recently pushed value. Most recently pushed value. Okay. So then push an item onto the stack is basically, we just see if TOS is equal to 9, then we can't push because maximum is, 10 entries, 0 to 9. Okay. 10 just means when array is what you call maximum of 10 values, right? It can have maximum of 10 entries. So